Thank you, Bill. Yeah, as Bill said, I did this last year. It was a relatively simple script. It wasn't a complete disaster, so I guess that was the bar to get me to try this again. I'm going to go for a little bit more of an ambitious goal this time. I think last year we loaded an image in VivoScript, then saved some QC images. And this year I'd like to, hold on, let me pull up.
And this presentation is still available on YouTube if you want to.
It's true.
Live the moment.
Yeah.
Did it go viral?
Sure it did. Let's see here. So I'm going to have a backup script here in case things go badly. But I'm going to have basically VivoQuant open on one side. Get rid of all this code. And I'm going to start by, similar to last year, I won't go into as much detail this time of what some of the resources are that are good to have open when you're VivoScripting, and a little bit of background on what VivoScripting is. So you guys have seen VivoQuant a little bit this morning. VivoScript is a JavaScript-based language to basically control a lot of the core VivoQuant functions and use them either to make a batch processing script or just to automate tedious tasks that you might have to do over and over again. We use it very heavily at inviCRO, and we have a few sites that use it pretty heavily as well. We do have a bit of a professional services business in terms of writing VivoScripts for people. If you don't like what you see here today, you can always feel free to contract that out to us, and we'd be happy to try to optimize your workflow as best we can. So to compare, if you've done your own programming in MATLAB and Python or whatever your favorite language might be, the functions here are much more high level. So you kind of call things like register images and apply a cropping range or something like that, rather than some of the more nitty-gritty operations, which you can certainly create at a high level for yourself in another program. But if you're already familiar with VQ in particular, it can be a pretty seamless experience, I think. Do we have the wireless mouse?
Oh.
Anywhere? I won't be too picky, but I'm not super great with the touchpad.
Sure. If you track that one toolbar and it's up on that screen over to yours.
To the right side?
Somewhere.
Yeah, I can try that. What does this do? Nope. Maybe I can just put it down here. Oh. Sorry, terrible with the trackpad. Oh, thank you. All right, thank you. So this thing doesn't fall. That's better. Let's see here. Okay. I can still see it.
That's not being broadcast.
Yeah. Oh, it's not being broadcast. That's a little better. All right. So I'm going to load a mouse hotel data set, which, if you're not familiar, is just two mice in a scanner at once. These two mice have tumors attached, and we have if I pull down the color bar, so the bladder is quite hot here, but if I pull down the color bar, you start seeing more of the anatomy, and you can see various organs here, and including a tumor low next to the legs. And so a common internal workflow is actually to separate out these. Obviously, these, because they come from the same imaging file, they share a lot of the same meta information, but there's obviously distinct aspects to them. So a lot of our workflows, together with the IPACs, involve separating them and treating them as independent images from a starting point, and then continuing on to do your quantification. So we have some nice tools for that here. I'm going to quickly illustrate to you how I can also save sessions in VQ. So any state that you have VivoQuant in, you can go to session, save. I've already saved it here, but if you save it, basically you get a snapshot of what you're currently working on, the operator you're in, the data set that you have, the ROIs, and it's a good way to share with the support team your state of the system, and let us try to help you with all the same settings and whatnot. Really great for the modeling tool as well, if you want to save a setup that you're in at the moment and go back to it later. So what I'm going to do in my script is actually load this session and just continue. So before I get too far ahead of myself, I'll open some useful resources here. Just open a new window, actually. So the VivoQuant VivoScript help guide manual should be the first hit. We have at our disposal W3 schools, JavaScript reference can be useful for some people. I'm not a super great JavaScript programmer, so I like to have this open as well. And maybe an additional VivoScript if you want to have one for reference. There are some located in the installation folder of VivoQuant. So at C, program files, inviCRO, VivoQuant, VivoScript. There's a number in here that you might find useful to start with, and hopefully the name is informative enough to guide you as to what they do. I've started setting this up a little bit already, so we could hopefully get a little more done this time. There's a number of global variables I've declared. There are kind of objects that you can grab, JavaScript objects for various modules in VivoQuant, including the data manager, data list, the main window, slice viewer. You might recognize some of these from using VivoQuant, and typically the functions that you call are either the functions of this master VQ object or of one of the submodules. So to load a data set, I can show you the sets here. In the help guide, we have save session and load session. You can provide a name to this function, and you can load the data sets. So I called that tumor seg, so I should be able to grab it from there. Get rid of it so that prove you I'm not cheating. And then, before, so you can run a VivoScript by going to file a VivoScript and finding it and opening it. You can also add it to your toolbar of quick scripts, so to speak. This is a little bit more convenient, especially if you're going to be navigating to it over and over again. So I'm going to find it here, and you give it a name, and then it shows up here. And then I can choose to do inline edits here. It gives you a quick little editor that doesn't look quite as fancy as maybe your favorite editor. There's also there's a run button. There will be a stop button if you wanted to halt it. And then there's also this evaluate one where you can test quick functions. You see I was testing one here earlier, but you can test just a simple function to see if it works, if you're doing it right, and so on. So let me run this, make sure we load the data sets. I did it wrong, obviously. So this is the VivoScript debugger. It's relatively new. It tells you, it gets triggered when something goes wrong in your VivoScript. So this is the one line I did. I'm 0 for 1 at this point. And you get a number of tools. Let me move this little widget here. So you get a number of tools here to play around with it. So there's a little evaluate dialog down here. I just typed load session for some reason. And then here you can just decide to evaluate any sort of VivoScript function kind of on the fly, like a command line here. So I can check where that function actually was. So this is in the main object or main window object, which I've saved up here as MW. So if I wanted to quickly test that, I can actually do this live with VivoQuant there open. Main window dot load session. Tumor sag. Hit enter. There we go. That worked. And here in this, on the side, you can see this. If you're familiar with other debuggers from other languages, you'll be relatively at home here. There's a list of kind of your local variables that you can access. So I can, for example, look at the main window object and actually see the names of the different functions that are available to me if I'm too lazy to go to the help guide. They're right here as well. So let me just go back to scripting and try to get a little bit more done. So now let me set the palette a little bit here too. In JavaScript, you can create functions that get reused later. In VivoScript, you can do it as well. And you can also put these in a different file and include it in this file. For here, I can call, we have this little convenience function called clip data, which will kind of set the palette or the window in a principled way by finding the 99.9th percentile intensity voxel value and setting that to our maximum palette. So effectively getting rid of some outliers. So here, so keep moving this around. Clip data. So I give it a percentile as a fraction. Test that out real quick. That looks pretty good. Okay, moving on. So just keep some comments along the way. Load data, set window, and then now let's actually split these mice into, or let's just grab the mouse on the right, for example. So the way we would do this in VivoQuant, if you're not familiar, is you can use a nice tool called Bounding Cylinders, which was actually implemented by Mary Germino back in the day. And you can find it in our tab here, the 3D ROI tool. Frequently the defaults will work, but you basically specify a cylinder radius of how big you expect kind of the tube in which the bed or the bed where the mouse fits in. If I hit apply here, you see it segments the two mice very nicely into two separate ROIs. So what I can do from here is then, for example, if I wanted the mouse on the right, I can delete ROI number 1, which is my green ROI, move these pixels to backgrounds, and I can mask out everything but my blue. So I can cut the background ROI, and I get just my right mouse, and then I can go. Well, let's see if we can get this far first. So bounding cylinders. So a really convenient function in the main window is set view mode, which basically navigates these two drop-downs up here, selecting a combination of view and tool/module. So here I can slice view and the 3D ROI tool. And what did I do? I went to here. I selected bounding cylinders. This is where this peak tool comes in handy. This little magnifying glass on a over a paper. I can use this to find any widget in my operator and figure out its name. The reason I'm is I'm going to basically reference all these drop-downs as by their name, and I can set any option in there. So a new feature actually to 3.0 is a nice little convenience function called VQ.setOption. So if I wanted to select this drop-down, forgive the name, it's called Magic Segmentation Selector. I reference it here. And I can give it the text of what I want selected there. It's a little bit nicer. In the past, you had to select the index into it, which is, if we have some drop-downs in some places have different indices depending on if you have certain license configurations, and if we added stuff, things kind of change position. So it's a little nicer to call them by name. Selector. And I also want, it's a good practice to kind of set all of the parameters in case someone had them to a different parameter beforehand. So go ahead and do that. This magic image. Reference image, cylinder radius. So to get other widgets, there's a get widget function, which allows me to call this guy by name. It's called magic radius, and it can set its value as such. It's a 16. And lastly, I can get the button magic something. I know it's going to be magic apply. Click, and in this way run my bounding cylinder method. I'm going to go crazy and try to do the next step too. Here we had two ROIs. I can look at my documentation, so there's, I believe, a delete ROI function. Yep. So I can delete ROI at an index and reassign it to another target, which is what you saw when I did that earlier. Mask out left mouse. We don't want that left mouse, so to get the current operator, do current op. So this gives me basically the 3D ROI tool object, and then delete. I can call it delete ROI on it. Everything from VivoScript is indexed by 0, like most programming languages. So it's the first ROI here is background, and then the second one was the left mouse, and then I'm going to reassign it to background, which is at 0. And then to cut ROI, I can do that with this nice function here also in the operator. And I can to either use the background ROI, which is the most common way to use this, or if I set this to false, it will cut whatever my currently selected ROI is in this drop-down down here. So just to make sure it does that one, do this, and then it has a nice little quiet mode to suppress additional dialogues and things like that. You saw it asked me to confirm earlier whether I was going to do it or not. So let's see how I've done here. Oh, I'm going to run it up here. That's the way I should do it. Great, loaded. Set my window. Okay, so this is the bounding cylinders. It is running, so that's good. It's asking me confirmation to proceed because I have ROIs already loaded from previously showing you how this worked. So a nice way to not force the user to see that sort of thing is to, before you even start, get rid of those ROIs. So I believe there's a clear all ROIs function here, which deletes all of them and assigns them in the background. I'm going to continue anyways, see if it did the other stuff right. Yep, it looks like it got rid of the left mouse. We're here. And then, so the reason I did that is now I can get rid of even more by using the cropping tool. There's a nice little auto crop feature which goes in from all boundaries and finds basically all the minimum valued slices and tries to get rid of them for you. So if I use auto crop and hit set based on the reference image, you see it finds all that extra stuff that I masked out, and it gives me the opportunity to crop it. And now we get these heavily portrait images that look better in this layout. So the next thing I'll want to do is crop mouse and layout. So I'm going to go to the cropping tool. Then how do I call auto crop? We have a cropping operator object. So auto crop estimates those boundaries for us. And cropping operator is relatively simple. Execute cropping does it. So. Sorry. Okay. We didn't get the dialog this time. That's good. Oh, I forgot to set up the layout. So the layout. Okay, so here are all our different layout functions. I want the 1x4. So, what object was that in? That's in the main window object. Great. Let's assume that works for now. So the next step that I would want to do is segment the tumor. So I'm going to go back to the 3D ROI tool, and actually first I'm going to show you that VivoScript is all about automation, but actually I think what can be underappreciated sometimes is the value of semi-automation. So there's a nice tool in here, or a nice function you can call in VivoScript called VQ.suspend. So you can do this if you want to debug the script, and you don't like the debugger. I can actually ask the user, if I call VQ.suspend, to segment the tumor themselves before moving on to the next step. So if the next step was just to save a QC image, which I can do by main window, save image. Let me find a nice folder for that. Get rid of that old one. It's on the desktop. I'll just type it. So that's right. Folder. I'll call it demo PNG, and then I'll save. There's lots of different QC images you can save. This references me to the other save image function I should use in the main window object. I can save a MIP, sagittal, coronal, transverse, or all of them together, depending on the type that you provide that function. So let me just show you. Now you'll get to see what the semi-automation is like with a step that goes right after it. So you see here down at the bottom left, we get this VivoScript suspended. I can kill the VivoScript up here, or I can say cancel to kill the VivoScript, or I can tell it to continue by hitting OK. So if I make the user segment this tumor, I could go over to my 3D ROI tool, get rid of my previous ROIs, add a new tumor ROI, make it green, and I can either paint it myself here, or maybe I could go to connected thresholding and use a connectivity-based thresholding technique to do it. Here I see the voxels are rounded or are around 3,000, 4,000, and then inside we're in kind of the 6,000 range. So I would go from minimum to, or sorry, minimum of 4,500 to the maximum. You see that gets me a pretty decent ROI. And then if I turn on my BTK and hit OK, I'm happy with it. See, there was a save image dialog that popped up, and we have a new my demo tumor.png here. That looks pretty nice. So the suspend, especially if you're kind of hacking one of these things up and you don't feel like figuring out how to do it all automated, sometimes it's just good to take bits and pieces, automate some of it, don't automate some of it. Don't do extra work when you don't need to. If you're going to do this a ton of times for different images, you can put this in a for loop and automate it to completely from start to finish. But it's always dependent on the application. Let's since we're here, let's actually do it. So you should be able to base this off of what we did earlier. So we went to the 3D ROI tool. We did most of these things, except we're not going to. We're going to use a different tool this time. We're not going to use bounding cylinders. We're going to use connected thresholding. We're going to use the reference image again. This time we need an input ROI. So we can use set option. CB magic input, I think it was. Background. And then this part doesn't matter anymore. And then the minimum and maximum. Oops. Magic threshold min. Magic. 4,500, I believe it was. And then this one we'll just set to the max. You can get the max of the image somehow. Max, get min, max, get max in the data manager object. We haven't used that one yet. dm.getMax, and you provide it the index of the image. We only have one loaded. Okay, and I want that apply afterwards up there. And I think that should do it. Let's try it. And just remembered I forgot something, so I know that this is not going to work because, so you see, there, we don't have a tumor ROI, and we can see that in our QC image too. The problem is I didn't set the seed point. So the seed point can be set through, we have the view controller typically. So here I provided a manual seed point, so I will have to do that here if I'm going to automate it. In the view controller, you know, here you can drag where your cursor is, or the currently selected slices in all 3 dimensions, and you can see the voxel value there in nanocurie per cc here. So if I wanted to set these 3 positions of 7, 17, 96, I would access the view controller, which I think is, yep, controller objects, sets position, sets the slice number to a particular value. I created I have a global object up here for the controller, VC. X of 7. And what were my other positions? 17 and 96. That's right. Nope, didn't work. So what we're going to do now is try to use our debugger to see what went wrong. So the debugger opens automatically if you crash, but if you really like it and want it there anyways because you know something's wrong but it's not crashing, I can, at the top of my script, add a debugger line with a semicolon or anywhere in the script, and as soon as it gets there, it's going to open it for you. And immediately pause the script temporarily so that you can do what you want with the debugger. So let me go ahead and do that and make this bigger so you guys can see. So what I'm going to do is, something went wrong with the position setting. So I'm going to set a breakpoint there, if you're familiar with breakpoints, and then I'm going to continue running the script and see how it goes. Okay, it paused here. Made it really tiny. So that's actually looking pretty good. It set that part in there. Let's see what happens to the other ones. Step over, up. You see, it's moving the crosshair. It's a little hard to see on the projector, but it's moving the same dimension. Obviously, that was my mistake here. We have you've provided the dimension as the first argument. They're all 0. So I can stop it. It'll continue running, and I can get rid of that debugger. So it's a real powerful tool to figure out what's going on. If you have you can see your variables, see what's in them, and figure things out that way. And also, I noticed that my VTK viewer is not on. I normally would have to click in the VTK controller object. I have update VTK and force render to kind of turn them on. So I can do that here as well. VTK dot see force render. Make sure we have it. Okay. Something happened. It did the position right. It didn't turn this part on. Yeah. It didn't crash either. Supposed to be update VTK. Well, I'll try here. So in my quick little tester, I can do VQ.VTK controller dot force render. Work there. What's different between this and that? Maybe I do need my debugger after all to see. Okay. Breakpoint, I'm going to set at, where was it? You guys can't see that, can you? Okay, we're here. It did render it. Oh, it did this a little. Oh, I'm doing this really early. It did this before cropping. That's why. See, we have a crop, and we should do it after cropping, because cropping will reset the VTK to go back to its current state. Makes sense. Okay. Put that down here. All right, I think we might be done. Fingers crossed. But you can see it doesn't take too long. It took a little longer here because I'm talking through it, but you can easily write one of these, and certainly our team on the image analysis side finds it pretty easy to chain a relatively short script together that gets all of this done, saves a QC image, and one last part. I didn't add a tumor ROI, so I didn't really do much here. So let me just do that. Sorry, I just got to do it for completeness. So I can add ROI, I believe here. Yeah. Current op add ROI tumor and provided a color green. You can provide any kind of color here. It doesn't have to be just the ones in the list. You can also give it RGB values of your own. So it's pretty flexible. Try this. Finish off. How am I doing on time? Okay. All right. There we go. Great. So now we have QC image with all 4 views open at the tumor with a segmented tumor, fully automated from start to finish. Great. Does anyone have any questions or anything they're interested in seeing here that I didn't already do?
So how would you get it connected? Is it possible to get multiple?
Sure, yeah. I don't know if I loaded lots of data sets here, but let's say it would look something like I would kind of take everything that I just put here and either wrap it in a for loop or more nicely kind of put it in a function. Say function process data set, and maybe you give it a name or something. And I put it all in here. So it's all living in this function now. And instead of loading, you wouldn't load sessions for this purpose, but if you had an IPAX, you would specify which data set you want on the IPAX here, and you would use the appropriate loading mechanism there. I don't have it hooked up to the IPACS right now, so it wouldn't be easily done here. But then here, you know, I could decide to iterate over some list of files or some list of IPACS projects. Process data sets 0, and I could do like for var I equals 0, I less than length. Like so, and you kind of get this this batch processing workflow in at work here. And so you can have any number of data sets in here. You just need the appropriate loading code here and go through it. Like this will just go through that one data set again. So I only have one in there.
Maybe you can show the DICOM browser menu with the.
Yeah. So here I only have. Oh, that's TJ's previous demo data set. But if you're familiar with the DICOM browser, you know you can look at your list of patient studies, your scans, and so on. Similarly, on the VivoScript side, you can grab. There's a nice, actually, IPACS.VQS convenience function, which I presented on last year. You should feel free to look at that one in more detail. But in the there, I can easily set up an IPACS repository by simply giving it its URL. I can iterate through different studies. I can iterate through different series, and I can filter them based on name, series description, modality, a number of different things. So all things that you might find recognizable from the DICOM XML DICOM API on the IPACS itself, to get whatever images you want, put those in a for loop, and continue from there.
This is, for instance, great for CT images, where you then just specify projects, and then you go through all the CT images, load them, save QC images somewhere, and even push them back to the IPACS store files on the web disk or in a local drive, and then go through all the images generated from the projects. This is something that we use a lot in our day-to-day work.
Exactly. Yeah.
Great.
All right. Thank you.